Now we can talk about homework 8, problem 9. Show that if x1, x2, blah blah is a Markov chain, then it is statistically determined by its second-order probability masses. The second-order probability masses means Pxi equals xi and xj equals xj, and ij is for 1, 2, 3, 2 integer numbers. And we know that the probability is 1x2 equals x2 until xn equals xn. And that means we should use the second order probability masses to show this formula, to indicate these probabilities. And we know that the condition probability formula, so that probability is this probability equals probability xn equals xn given xn minus 1 equals xn minus 1 until x1 equals x1 time the probability of xn minus 1 equals xn minus 1 until x1 equals x1. And we can still use the conditional probability formula. So the whole formula equals the probability xn equals xn given xn minus 1 equals xn minus 1 time the probability of xn minus 1 equals xn minus 1 given xn minus 2 equal xn minus 2, and all like this until the probability of x2 equals x2 given x1 equals x1, and we should to time a probability of x1 equals to x1. And now all this part is conditional probability and this part, so that means we should to use second order probability masses to indicate these two parts. We should to use second order probability masses to indicate this part and this part. So for the first probability, it is very easy that it equals the all the k, and x1 equals x1 and xj equals k. And for the second part, the probability of xi equals xi given xi minus 1 equals xi minus 1, that should be as the formula, as the conditional probabilities, that equals xi equals xi and xi minus 1 equals xi minus 1 over the probability of xi minus 1 equals xi minus 1. This part is a second order probability, and this part we prove here. It can also be shown with the second order probability masses. So we say that this probability could write as second order probability masses. So the Markov chain is statistically determined by the probability masses.